My name is Paul Armstrong, and I'm a solutions architect working here out of the UK. And in this session today, I'm going to talk through how you can make use of video, and in particular, focusing on ingesting, storing, and the challenges around archiving. I'm not going to look at things like mass distribution, and we're also going to look at some of the more advanced use cases of how you can actually do some ML analytics on top of these types of use cases. There were going to be a couple of demos. We will see how they go, but the connectivity isn't what I was hoping in terms of the session. In terms of the session, I am going to be showing some code. I recognize this is a big room, but the code's more about showing the sequence of events and the connectivity of the different services. So if anyone does want to touch base in more detail about the code, please talk to me afterwards. So when you're talking about video ingestion, I always, when I start talking to customers about this, I go back to our basic pipeline for management of data within the data lake. You require a mechanism for how you're going to collect your data, how you're going to store it, what processing you're going to do on it, what ETL processes you're going to run on it, how you're going to consume, so visualize your data. This is something that everyone's fairly comfortable with. You do this quite frequently with transactional data. We do it with log data. But what we're seeing now is more and more devices coming online where we want to get analytics and capture that useful information out of those data streams. So for example, we're talking about video in this session, but voice. Voice is just important. You now want to transcribe voices. You want to do sentiment analysis on maybe your contact center recordings. So suddenly what we're really looking for is very, very different sources of information to feed into our data lake and how we can process them. Now, last year at reInvent, we announced Kinesis video streams. And one of the challenges we've been seeing with our customers is when they're running solutions such as CCTV, how do you actually integrate all of your devices and store your CCTV footage at scale? It's really difficult to scale to millions of devices. How do you support the different cadency, the latency, the different firmwares, the different cameras? And how do you make this into highly scalable, highly available storage? Something that you're used to using with other AWS services. But also, you need it integrated into the security, and you need easy-to-use APIs to actually retrieve, process, and replay video. So Kinesis video streams came. The objective of Kinesis video streams was about how can you stream the video from millions of devices, make it easy to build these applications, and integrate it in, as we showed on the opening slide with the data lake, to the analytical tools that you're used to using now. It's got to be secure, durable, and fully managed. So when you look at the pipeline for Kinesis video streams, it follows the standard data collection process. You need a producer. Your producer needs to be able to take the camera from your device, in this case a camera, and send it through the Kinesis video stream. Now this is slightly different from those of you that are used to using Kinesis in that the producers are very, very much designed for high throughput. So they're very, very specialized. Then you have the Kinesis video stream itself. How do you actually consume that data? Maybe you need to consume it in real time. Maybe you need to store it and index it and access it securely. And then you might need custom applications, maybe sharing that data with third parties. So if we start at the beginning of the pipeline and work through, Kinesis video streams producer SDK. This is all about how can you connect and stream from different camera sources. It's got to be flexible. You may already have thousands and thousands of devices. How can you integrate them into the producer SDK? It's got to support out-of-the-box integration with AWS, as you would expect for using any of the other APIs. It's got to be able to put stream frames or buffered fragments onto the stream. So it could be that there's a buffered delay. It could be that you're trying to stream in real time. But then you want to be able to build those custom integrations using the tools that you're familiar with in a secure way, but still be streaming that video data on your preferred transmission scenario. It could be one-to-one, or it could be that you're passing this into something with, where you've got mass distribution, where you're using services such as Elemental. So what are your ingestion options? Well, you can stream directly from the camera. And we've got partners such as Viviotech that actually now are putting drivers and our producers on their cameras so you can stream directly to Kinesis video streams. If you already have IP cameras, what you can do is you can put in place a proxy. Put in a local proxy, and rather than actually storing the data locally across those cameras, you can actually stream it to the video streams and then have it for the long-term durable storage and analytics. Or you can do some analysis at the edge. So you can look at how can I do the processing and only actually stream data when I need to. So if I have a use case, for example, of detecting faces, and we're going to explore that later on, run that processing on the camera and only actually pay for your downstream processing when there's objects of interest within the camera frame. Now, Kinesis video streams, it's really important that it transports video data. Anyone that's worked with video data knows that this is quite complex. You've got to manage your frames, you've got to manage your fragments. But also, this needs to be durable, and so it needs to be able to be supported in real time and in ad hoc for archiving. And the way Kinesis video streams are designed is maybe different from people who are used to using other Kinesis variants, is that you have a single producer publishing data to a single Kinesis video stream. Your producer has to have the capability to securely put the data onto the stream, and this can be from multiple hardware devices. It can be from security cameras, which we're focusing a lot on in this talk, but it can be body cameras, smartphones, various other devices. And then you have your consumers. How are you actually going to take the data, process it, and analyze it off the streams? So one of the scenarios that I've been talking to customers about a lot is I work in the UK with travel and transport. And regularly, when there are security incidents, they need mechanisms for how they can securely and quickly share data with the third-party security services. So this is an example of that process where you have your producer from your camera, maybe it's on camera, maybe it's via a proxy. It's putting that data onto the video stream. And then what we're doing is a very, very simple process of actually retrieving that video data from the stream. So in this case, we're using HTML and API gateway to poll a Lambda to get the data. So we'll just take a look at how this works, just to show the simplicity of how quickly you can share this data. Apologies for the image, but I could only have an approved image of me, so we couldn't find any models in the time frame. So what this is doing here is something that you're familiar with. It's doing a list streams. So it's calling the Kinesis Video Streams API, and it's actually listing all of the streams I'm authorized to see. So you can see that you could authenticate your users by cognito, give them access via roles to the streams that they have access to, and produce the list. So here I've got 3 streams, a DeepLens, an IP camera stream, and a web camera stream. Then I'm actually passing in the time and duration to the stream of the footage that I need. So I create an endpoint on the API. I then make the call to that endpoint to retrieve my archive media, and I'm pulling the data from the payload and storing the MP4 output in S3. Then with that output stored in S3, I just generate a pre-signed URL, which I'm then passing back to the HTML page. Now, you're starting to see how suddenly you've now got your data in S3 and how easy that is to share with third parties. You could write custom applications that third parties could have direct access to their streams, or there are other approaches. So one of the things that you want to do with video is you want to actually do analysis. And maybe you want to start to get the data insights that are captured in your image collections and in your video collections. And we announced back in 2016 recognition. Now, recognition is really important for doing analysis of video of individual frames. So we're talking about images in this case, object and scene detection, being able to, from an image, capture the metadata about what objects are in the scene or what the scene is. Facial analysis. On this talk, we're going to focus predominantly on facial analysis, but we're looking at what faces are in the frame. And can you do comparison of faces? So you can actually take the feature sets from faces and do comparisons. And do facial recognition. So upload faces and actually do comparisons of those faces against the facial recognition. And some of the newer features that have been added to recognition, to those of you that from the original announcements, is we now have the ability to do celebrity recognition. So this is about actually finding celebrities and tracking celebrities. And there's a few use cases where large events, this is quite interesting. And of course, image moderation, having collections of images and looking for inappropriate images, which is really important. So, celebrity recognition. The way this process works is you upload the image, as we've done previously, and you get returned back the JSON data showing you the information on the celebrity face, where the face was detected, the bounding box, and information on the probability of who the celebrity is. And we have customers that have been using this facility, such as C-SPAN in the US, who in 3 weeks were able to index against 99,000 people. So this index was created in a day, and it was saving 9,000 hours a year in curation costs. So this was a manually intensive process that could be automated very, very quickly just with doing frame sampling from their existing video streams. And if you look at the architecture, you can see that it's very, very straightforward. You have your camera encoders, you're extracting your stills, and once you've extracted your stills, you're putting them in S3. Once they're in S3 events are then triggering for downstream processing. They're calling recognition, and any of the recognized results are again being stored into S3, where they can be accessed by the end users. Now, this is one use case, but another use case probably that's closer to home is some of us might be aware that there's a wedding happening in the not-so-distant future. And in the royal wedding, Sky have announced that they're going to be using Kinesis video streams and recognition for actually capturing the celebrities that are appearing in the royal wedding. So you're going on their live feeds, you're actually going to see the names being put forward of known celebrities. So they're using that for the tracking to help enhance that customer experience and their coverage of the royal wedding. Now, I was going to try and show a demo here of this running, but looking at the way that the Wi-Fi is running, I'm not brave enough to attempt it. But what we were actually doing was I wanted to show the simplicity of actually using the recognition API. So on a single HTML page of a few lines of code, what we're doing is taking a snapshot of a face, from that face, capturing the metadata in terms of information about am I male, am I female, am I wearing glasses, etc. And also, I was doing a validation of that image against a stored set of images. So am I an Amazonian? Am I in the collection of people, of the staff that are working for AWS? And so this code sounds like it's really complicated, but actually it's very, very straightforward. And I always start with this to sort of introduce how you would then use recognition to put it into your more complex downstream processes. So what's happening? Well, basically all that's happening is on the camera, on the Mac, I was taking an image blob. That image blob I was then passing through via the parameters into recognition, detect faces. What recognition then does is return that metadata about the image. So you can see it's got the face detail. What was the bounding box on the face? What was the age range of the face that was detected? Other information such as the smile. Am I wearing eyeglasses? Am I wearing sunglasses? Have I a beard and a mustache? And so forth. And then when I'm doing a search against a collection, all I'm doing is searching for a face in a known collection. So I pass it a collection ID, in this case Amazon, and then I search the faces by the image, again passing in that blob from the image to see if I find any records. Now this was just using the JavaScript SDK on a HTML page. So a single page just on a loop, polling and actually showing the information in real time captured. Now, that's quite simple, but actually that's not very efficient because you're processing continually. In this case, it's on a 500 millisecond loop, which is partly why the Wi-Fi is not dealing with it very well. But that's not very efficient because you're paying for all of those calls to recognition, regardless of whether you actually need that information. Now, there are more advanced use cases for recognition where you start to introduce them into your decision trees and your processing pipelines. So most use cases require more than just capturing basic metadata about your users. So you can see that the captured information can trigger downstream events, maybe by S3 event notifications, maybe via Lambda, maybe even via step functions. And examples of using DynamoDB for storing of that information as well. Now, in the example that we have later on with the DeepLens, I will show how we're sort of bringing all of these downstream processes together. But simple use cases, as we've touched on as a story with Sky, is the persons of interest near a celebrity. You can do multi-pass motion detection enhancements. So you're looking at how do you actually do more intelligence into the end devices. And we'll touch on that a bit later on in the closing examples. And also, you can maybe start to have use cases, again, from a travel and transport scenario, of people maybe going into buildings and then leaving and leaving behind possessions. This could flag something of interest to the security authorities. So when you're talking about these collections, what you're now doing is talking about how do you actually store collections of images that can be processed by a recognition. So here's some examples of using the API. So we're calling the create collection, and we're creating a collection called persons of interest. And then all we're doing is calling the recognition API on index faces, passing it an image, and adding it to that collection ID. And under the covers, what recognition is doing is processing that image, indexing it, capturing out all of the features that it will then use when you do subsequent comparisons against that collection. It's not actually storing the image itself. It's just storing metadata about the image and a primary key, which is its external identifier. And you can see for the recognized celebrities, very, very simple call. You call the recognized celebrities API and pass in the image. And it will give you a return of the level of confidence of a celebrity that's been recognized. And as we touched on when we're searching the collections, you can see how we're searching faces by the image and searching in the collection ID for the persons of interest. So the evolution of this, and these were some of the new features that were announced in reInvent last year, is Amazon Recognition Video. Because the behavior of you is very different in front of a still camera to in front of a video. Traditionally with a camera, you stop and you smile and maybe you pose. Whereas with video, it tends to be a lot more natural interaction. So again, there's the object and activity detection. There's some other interesting features like person tracking, so being able to track individuals as they're moving through the frames in the video. Again, facial recognition against known collections, as we've been talking about, and real-time live streaming. So actually now you can start searching for individuals on your real-time streaming. So for example, if you have people of known interest, you can start searching real-time feeds for when they've appeared on cameras. Again, a use case that we've been talking with travel and transport, working with the security services. And of course, the unsafe video detection and the celebrity recognition detection. But the difference here is, what you're now doing is you're running a recognition video stream processor alongside a normal stream, a video stream, rather than you having to extract the frames and sending the individual frames through to recognition. So in this example here, you can see that what's happening is the objects are being detected in the frame, and the individual people are all being tracked as they move through the frames. So what you're now seeing is you've got that frame-by-frame analysis, capturing of the recognition of people, and then the recognition of moving of those people through the frames. So use cases for this. You can see that for those of you that may be aware, we've launched Amazon Go over in Seattle. And Amazon Go is one of our stores where you actually walk in, you scan your phone, you walk around, you pick up the items off the shelf, put them in your bag, walk out, and they're automatically added to your basket, and you're charged when you leave the store. And this is where you can see where this technology is coming from, in that you're running image arrays in the ceiling to actually deal with the tracking of individuals and also the actions that they're taking within the frames. So you can see that there's use cases for CCTV for building entry. You can see that one of the use cases that we've been working with is when you've got on building sites, making sure that all of the people that are actually on the building site are authorized to be there, are authorized to have the relevant safety credentials. Other interesting ones are, for example, trespassing on the railway track. If you detect a human on a railway track, that causes, most of us who travel by train here in the southeast know that any impact on the rail network causes significant disruption. And actually, if you think about being able to detect for trespassers on the railways earlier and to take mitigating action, can help with reducing some of that disruption. We've touched on looking for celebrities, and there's lots of interesting use cases now about working out who's at the front door and do you actually want to go and answer the front door now. So you can see if you were to take the scenario of who's at the front door, you're starting to see a common pattern emerge in terms of all of these use cases. What you're seeing is you have a live street camera, you have your producer application streaming it to a video stream. You may set that video stream to only be archiving for a few hours, or you may decide you want to keep it for the last 24 hours, running a recognition video stream on that continually and sending out alerts. So what happens is the recognition video stream detects a known face and then sends out to a traditional Kinesis data stream that face has been detected. You can then process that via Lambda and maybe send out an SMS message via the SNS service. So when you look at the workflow, what are you doing? And you're starting to see, this is getting repetitive, I hope. You index the faces and you create a recognition face collection for doing the matching. You create your video stream that you're actually going to put your stream onto. You create your recognition stream processor. And as you can see in that logic on the right, what you're doing is you create that stream processor, you tell it what your input stream is, you tell it what the output stream is, where you want to put the results of known matches, and you tell it the collection that you're searching against. So you can see now how you're comparing videos and you've got two stream processors running together. And whenever a hit is found, it produces JSON similar to that in the bottom right-hand corner, showing you the search response, showing you the detected face, again, where the bounding box is, the similarity match, and the external image ID, so you can maybe look up that image from somewhere where you're storing it in S3. So again, what's the requirements for your application code? You need a producer. You need your video data generating device, and on that, you then need to be using your producer library. Currently, the Kinesis video streams has producer libraries for Java, for Android, and for C++. And these are being developed all of the time. And you can see now that you've got your custom application. In this case, it's a Lambda function running Python. And this is triggered by data arriving on the Kinesis data stream. But that downstream processing is very, very similar to the analytics that you're doing today. Now, I was going to show a demo of the DeepLens, but there is one here. But unfortunately, I'm having trouble with the connectivity. So I will walk through how the solution's working, and if there's time, maybe we'll see at the end if we can get it connected up. So what is DeepLens? DeepLens was something that we announced back in reInvent last year. And DeepLens is really about helping you start to look at your machine learning, and how can you actually start to experiment and deploy your machine learning models to the edge. So it just has compute capability of running your deep learning models on the actual camera itself, and it can perform inference at the edge. So all the use cases we've been talking about to date have all been around capturing how do you actually stream data continually and archive and store it. What if you don't want to do that? What if your use case is, I only want to transmit data when I've detected a face in the frame? So how can you run a model on the edge of the device rather than having to send the whole frame to recognition? What if I just want to detect a face, get that bounding box, crop it, and then send it through for downstream processing? Suddenly, I'm only paying for downstream processing when I have an object of interest, and I'm also doing this in a much more reduced bandwidth. So the solution that we've got here is using DeepLens. And what DeepLens does as a project is via the console, you can create DeepLens projects. And the DeepLens project enables you to import your models. Maybe you've generated something in SageMaker. It enables you to manage your Lambda, and it also manages the deployment and configuration of Greengrass. So it manages your certifications and your secure access back to your IoT devices. So in the case of the camera we have running here, that's unfortunately not connected, it's running Greengrass on the actual device itself. And Greengrass is running the model to actually track the faces it detects on the frame. And when it detects a face, it crops it and streams it through for downstream processing. And we'll go through the downstream processing as before. But you can start to see that all you have here is, rather than it using a producer, you could put a producer on the camera and use Kinesis video streams. What we have a use case here is what we're trying to do is actually detect a face. And if we have a face, we want to display that we've detected the face with known information about that face. So the way that this system works is, say I walk past the camera, it knows me, it will display an image I've preloaded with my job title, welcome, and a logo if I'm smiling as I walk past the camera. And the other thing that this example is doing is it's actually doing sentiment analysis. So I'm tracking all of the sentiments of all of the faces of the that walk past the camera, whether they're known or not, and then just streaming them through to Kibana. Again, very, very simple, and we've seen lots of use cases for using Kibana in this way, but maybe not with sentiment analysis. So what's happening on the device? Again, we couldn't find a better looking model, so it had to be me. But what's happening on the actual device itself is you can see that I'm loading into the GPU on the model, on the camera, the model. Then what I'm doing is I'm doing inference. So I'm actually doing inference on the edge. So I'm capturing the last frame on the actual camera itself. And then what I'm doing from that is I'm resizing it so that the input and width and height that the model will support. And then I'm doing inference on that actual device itself. And what do I get back? Apologies, this is quite small. But basically what I get back is a face boundary again. Now, one of the things I found with recognition is if you had too tight a face boundary, it wouldn't detect it as a face. So I've actually widened the boundary when I have detected a face in the frame before I crop it and send it through to downstream for Kinesis. And what I'm also doing is adding the labels. You can see there, I put a bounding box around the face. So I'm just using OpenCV, overlaying that onto the image very, very simply, and storing that on a FIFO stream on the camera. So what you can actually see is on the camera itself, it can track all of the known faces that are running. And if you if you go down to the Innovation Hub, you can see that there's some guys that have got a similar type demo where they're actually doing the coffee cup challenge. So I'd recommend going and having a look at that in action. So I'm now in a position where I have a camera that I've set up that is only actually sending captured faces for downstream processing. And in my use case, what I want to do is I actually want to have a display of an approved image with approved information about the individual. So in this case, I've got a very simple uploader, which is saying I need to know what I'm going to call my external image. I need to know what my member name is, what's my first language, what's my job title, and what is the image that I'm actually going to load. So it's just a bulk uploader. You could have a use case where you allow people to take their own pictures and upload those to the collection. But for most of the use cases I've used, I wanted to have some control over the pictures that were displayed. Then all I do is very simply process this. I resize the images to a size that's appropriate for the display that I'm using, and I add the images into the collection. But the other interesting thing is here as well, I'm also now storing in DynamoDB the additional metadata. So I've now got a meta store of additional information that's joined to my collection. So I can enrich my display with the information that I've stored in with my collection. So I'm now in a position where I have a set of images stored in S3. I have a set of metadata, which I've stored in DynamoDB. And I have a recognition image collection, all of which are joined together. So now I can process those images from the stream. So I'm putting the cropped images onto my Kinesis stream. And what I'm doing now is just actually taking them off the stream. So very, very simply, running a Lambda function, using OpenCV, taking the image, and when I detect an image, I'm just calling the search faces by image, which we've touched on earlier. Pass in the image bytes, and determine if I actually get a match. The other thing that I'm doing is getting the sentiment from the faces that I detect. So this is doing two things, It's if I'm looking to send to Elasticsearch, all I do is I determine what emotions have been detected and send those across onto Firehose. In this case, I'm using Kinesis Firehose because I can just use it to actually put directly into my Elasticsearch service, which then enables me to do the visualization with Kibana. And I'm also, one of the things that obviously image recognition is in the press a lot at the moment, and you have to be very, very sensitive about how you're managing and processing and storing of images. So in this example, the only information that's been stored is the approved information that's been given to me by the user. So you've approved to give me basic information about your role, and you've approved to give me a photograph. Interestingly, most of the photographs I get given when I'm running this in demos are of 10 years younger of the individuals, which is interesting to see if they still match. But the important thing here is the processing is just actually taking the image, capturing the information out of the image, and then doing the comparison, but not storing any of that captured information. So in this use case, all I'm doing is matching to say, does the image have any comparison to something that I've got stored? If it does, then I'm actually processing it and displaying the results. So my detected faces viewer, unfortunately, because I couldn't run the demo, what would happen is as I run in front of the camera, walk in front of the camera, the detected faces viewer would pick up, recognize my face, and show the preloaded image and some information about me. And again, all I have here is now, you're starting to see how this all comes together. All this is doing is processing a DynamoDB table. And all I'm doing with DynamoDB is looking for the known faces in the last minute that are distinct and displaying them and returning them to my HTML page. Now, why am I using DynamoDB? Well, for a single camera and a single set of faces, there's no real loading here. But we're talking about how could you scale this up to thousands of devices. And using DynamoDB for capturing and partitioning based on your collection IDs would mean that you could use the auto-scaling capabilities of DynamoDB to cost-effectively scale this up as you introduce more and more cameras. So what you can see is, well, I'm writing it to DynamoDB. I'm determining my unique images detected. Once I've got those unique records, I'm just generating a pre-signed URL to display those images. So again, throughout this process, and no time are we exposing the data for longer than is necessary. So the pre-signed URL is only available for a brief period of time while the HTML page is loaded up. And one of the other things is there is a logo on there that if you happen to be smiling, then I would show a logo to say that you've got the company smile. So again, that's using the sentiment analysis to actually do some processing. Now, with the sentiment analysis, what we were doing was we were actually running the processing of capturing a set of sentiments from the metadata that's returned and just displaying them as a time series chart. It would have been interesting to see what my emotions were while I was trying to set this demo up. But what you can see here is some of the emotions I was showing while I was actually doing some of the configuration. So you can see I mixed between happiness, sadness, and confused, and I think this is the life of any programmer in terms of trying to get their code debugged. But what you're starting to see is you're now getting some interesting data about real-time processing of sentiment. So for example, I had trouble getting this camera working, but it would have been really interesting to have cameras set up all around this auditorium and watch the sentiment in the room in real time against the talk. And at what parts in the talk were people confused, sad, happy, unhappy. And you're really starting to get some interesting data about how you can utilize and maximize the customer experience. Unfortunately, I can't share it because of the connectivity problems. But what have we seen here? So when we set up the talk, we were talking about how do you manage ingestion of video? How do you manage the archiving of video? How do you manage the easily sharing of this information at scale? So we've set up a simple HTML page and shown how you can do image recognition processing on the actual devices themselves, on the edge. But this is inefficient. You know, you're just polling recognition. You've got no logic there, and all you're doing is displaying out the output metadata. How do you process live video? Again, you have your producer, and you use your producer to put data through onto your Kinesis video stream. And then how is your stream processor interacting? Well, you can interact using recognition video to have a stream processor acting on your live video, and you can archive and share the video. So quite useful use cases, and to do this at scale and securely. And then the final example was about custom image processing at the edge. So here we're running ResNet with SSD on the actual camera itself just to extract image information. Once we have those faces that are detected, we crop them and stream them for downstream processing. Now also, we're using recognition in this use case, but it may be that you will build your own customizations, and you will also, potentially you will build other use cases in terms of maybe you want to do unique image object detection, and maybe you need to train your own models using tools such as SageMaker. And again, all you can see is that what you will be doing is you will have your SageMaker endpoints, and rather than calling recognition, your lambdas will be calling inference on those endpoints of those SageMaker pipelines. So what you're starting to build is a set of solutions that you can extend end to end. So a few further links. What I've tried to do is pull out all of the things that we've talked around in this talk. There's an example of the model that we're actually running on the camera, just so you can see how that hooks into MXNet. We've got SageMaker. I would recommend exploring SageMaker because SageMaker is really interesting for how it can manage the end-to-end delivery of your machine learning pipelines. So with SageMaker, it's about solving how do you get your data machine learning models into production. And then image classification. If you want to do some different image classifications, there are some pre-built models that you can have a look at and use within SageMaker. And of course, Kinesis video streams, DeepLens, and the Elasticsearch service. Elasticsearch service is more there for completeness because there's nothing new there. That's something that anyone is running the analytics, running analytics today is aware of. So please unfortunately, because I'm not allowed to run lots of cameras and get the stats automatically, we do appreciate your feedback. So please do complete the session surveys in the mobile app afterwards. We're a couple of minutes ahead of time because, unfortunately, I haven't been able to get the demos to work. But if there are any questions, please come down to the front, and I'll be happy to take them in sort of the last 5 minutes. It's a big room, so again, thank you for listening, and I hope this has been useful. Thank you.